Okay, here we are in the last graphing section. So we've been through 3 graphing sections. The first one helping us understand sine and cosine. The second one helping us understand phase shifts that go on with those two functions. And then, and I guess it would be representative of any trig function or any algebraic function in terms of phase shifts. And now we're focusing on the last two. Well, the third section was tangent and cotangent. Apologize about that. And now we're focusing on the last two graphs, the secant and the cosecant function. And so the trick for the secant and the cosecant is to remember that they are just inverses of either sine or cosine respectively, as shown right up here at the top, right? Cosecant is 1 over sine x, secant is 1 over cosine x. And so the first one they point out is secant. And so you want to notice that the lowest value secant ever, well, I got to be careful how you say that. The lowest value it obtains is negative infinity, right? And then it can come all the way up to negative 1. Then it hops up to 1 and goes up to as high as infinity. Now, that may feel like, oh, that's a lot to remember. No, it's just a flip. It's a flip of a function. So let's take, they're doing secant first. So this is, if it's not clear, this is y equals secant x. Let's go get its graph. So how do we get its graph? Let's start. Actually, let me move that over. Let's start with the coordinate axis. I'm going to just move that coordinate axis right back here and then come right across here for my 0 line. Now remember, secant's the flip of cosine. I'm going to make that a little bit straighter. Sorry about that. See if I can follow that line a little bit better than I did that first time. Yeah, that's better. Okay, so secant is the flip of cosine. So I'm going to do something in blue. Blue is not part of the secant graph. The secant graph will be done in black. So remember that it's off of cosine. So let's just draw the cosine graph. Cosine starts at 1, falls to 0, and I'm going to put it as a dash. Then it goes down to negative 1, comes back up through 0, comes back up to 1, comes back down. Oh, apologize. That was a little bit too tight. Okay, comes back down to 0, down to negative 1, up to 0, and all of this is what it looks like. And then over here it has a portion of the graph, right? Down to negative 1, up to 0, and it just keeps going. So that is in blue because that's just a helper graph for me. Remember these points, that it's crossing 0 at, and I'll put these in black, at pi over 2. Right? It's down at negative 1 at pi. Then it's 3 pi over 2. Back up to 1 at 2 pi, right? There's its period. This is negative pi over 2 over here, and negative pi, and negative 3 pi over 2, right? And so forth and so on. We can label out as much. Don't get so crazy. What I need for you on an exam or even in the homework is just to show about one period at least of the function, and I'll understand that you know what's going on. So far I haven't done anything other than say, well, secant's based upon cosine. So now when you do 1 over, we got some issues. So I'm going to come in here in red. This is going to be a vertical asymptote for the secant function because that's when cosine is 0. Well, if cosine is 0, then the secant of, let's say, at pi over 2 would be equal to 1 over the cosine of pi over 2, which is equal to 1 over 0, which is undefined. And that's going to happen at any odd multiple pi over 2. And so let's just go put those all in here. Anytime that cosine graph is 0, we're going to put in these asymptotes. We cannot cross those guys. And you'll deal with a lot of asymptotes in your next class, right? Because in your pre-calc class, you'll have a lot of asymptotes. And so we'll take our time here. We'll do the next one ideally a little bit quicker. We're still not done. At no point do I have anything in black. Black is going to be my secant graph, and I haven't done that yet. Here's the secant graph. It will just go to the top of any one of the curves and draw basically a parabola that goes and hugs those lines. Go to the bottom of any hump and do the same thing. This is what the secant graph looks like. the stuff in black. Now the red part's necessary because we need to know where its asymptotes are, but the blue part is only necessary for us to quickly graph it. So keep in mind when we ask you to do a secant or a cosecant graph, we're basically just asking you to draw a sine and a cosine and the humps right off of it. So if you know how to do sections 4.1 and 4.2, you'll do great in this last one. This is what the secant graph looks like. Now technically, this should be removed, all this blue. So let me come in here and just take out some of the blue that's here, trying to leave as much of the red as possible. Whoops, I got rid of a curve. We'll go back in there and put that one in. So I've seen people draw it without this, but most of the time I see people drawing it with the curve. Okay, come in here and put my line back in and make sure I get this curve that started right here and was going up. Okay, they don't have to be perfect, just the general shape that's going on. So when we go to do y equals cosecant, you know exactly what we're going to do. The same thing, except it's all going to be based off of the sine graph. And we know sine of 0 is 0, and it must go up from there in the first quadrant. Actually, let me make that dotted. It's going to drive me nuts if I don't. And so we just quickly draw our sine graph. Oops. And draw our sine graph coming in there. So we know when we're going to go graph cosecant that we have asymptotes anywhere the sine was 0. So right along the y-axis, right? At x equals 0, makes sense. At pi, at 2 pi, at 3 pi, at 4 pi, at negative pi, and make sure all of these are in radians, right? So we're back to radians again when we do this, and so it's nice that we're bouncing back and forth. So this is pi over 2, this is pi, 3 pi over 2, 2 pi, and so forth and so on. I'll just label that as 3 pi and 4 pi. You can get the idea. Negative pi over 2, negative pi, so forth and so on. Let me put that negative pi over 2 up here so it's not as weird being away from the axis. Okay, awesome. So what do we do to finish? No problem. We just go to start at any one you want and make sure you do all the bumps that go off of this. And it would agree with the chart that's on the other side, right? That's off to the left over here. That when you look at pi over 2, you should be seeing a 1. It goes up to infinity. You can get as high as we want. And it shouldn't be shocking to you that as we get closer and closer to where the sine 0, that we're getting super huge, right? Because you're dividing by smaller and smaller numbers. That's why we're going up to infinity. That'll be a big, big concept in your next class about going out to infinity. So what's left? Okay, what's left is just to handle some phase shifts, some amplitude stuff, but you're going to handle that all through the cosecant. So I really want you to view this as a review over 4.1 and 4.2. I apologize, I might have said cosecant. You handle that all through cosine or sine, and therefore you're going to be looking at a knowledge of 4.1 and 4.2. So let's go ahead and draw in a coordinate set of axes. Now remember, these are floating for me. I might change it. Look what we have. Maybe we can make note. We have an amplitude adjustment, and we have a phase shift, right? So we do have a 4.2 problem that we're having to deal with. And so this next one, the B one, is really good, but let's handle the A one right now. So what do we know? We know cosecant has a base of sine. So I'm just going to draw my regular sine graph. I'm going to use the regular coordinate axis. I'm going to put it in blue, except I'm going to note that I have a new period of 2, new amplitude of 2, and I'm being turned upside down. So instead of my sine graph going up, my sine graph is going to start at 0, 0 and go down. Now this is without the phase shift, right? I'm not trying to do as little as possible. Then we're going to go up to We're going to go up to 2 and back down to 0, down to -2, up to 0, down to 2, or up to 2, down, down to -2, up, and so forth and so on. Okay, then, so this is where I'm going to be helped out. Let me just go over to this side too and put that in. Now I don't want to label anything yet. What I want to do is handle the phase shift. I'm not going to even do my asymptotes or anything just yet. This thing is being shifted pi over 2 to the right. So if it's being shifted pi over 2 to the right, then what happens is this graph is going to move pi over 2 to the right. So here was my 0. Now this is the x-axis. This is the 0 part. I don't like that so much. Let me just come in here. I tried to fix that top one when I wasn't drawing it straight. So straight down here. Awesome. That's how I would recommend handling phase shifts. So everything is pi over 2 back. So this is pi over 2 right here. Now plug it in. Does it make sense? X minus pi over 2 is 0. Sine of 0 is 0. It's exactly where I should be. Times -2 is still 0. Now this is sine. So how do I get the cosecant? No problem. So what we've done right now is a 4.2 problem of y equals -2 sine of x minus pi over 2. That was our first step, and it was done in blue, right? So I'll highlight it in blue. Our second step is easy. Put in asymptotes. And I'm going to highlight that statement in red, because where you'll see them up here is in red. Now it's everywhere that function will cross the x-axis, and it's absolutely going to cross at pi over 2. It's not going to cross at 0, because at 0, when you plug 0 in, you get negative pi over 2, and so you're high in there. So we just go and put these guys in. We've invested all of our time doing that blue stuff. This is easy work right here. So that's what we want you to think, is 4.4 is not adding much on. It's actually giving you more practice with the earlier stuff, which is great. You're going to definitely have some graphs on the exam. Then what you do is finish. So the third step is to draw your parabolas. And so we're going to start here, and we're going to go up. Start here and go down. Start at the peak here and go up. Peak here and go down. Right. And I probably should put more labeling in. I'll go do that really quick. But you can totally leave your graph like this. You do not have to erase the helper function at all if you don't want to. But technically the graph is the stuff in the black, right? The red lines, I guess, should be there because it'll help us out. So you just go, and there's been no period adjustment, so it's pretty easy to go through and label all of those. And you can just do enough where I get the general picture, or you have the general understanding. Pretty nice. Now, I mentioned B was really interesting. B is going to be in the homework, most likely on the exam. Maybe I won't have you graph it, but I'll at least have you tell me what the period is and the phase shift is. And so what we want to make sure that we understand is what's happening. We have this thing have an amplitude adjustment of 3. Right? It has an amplitude adjustment. It has go up 2 that needs to be accounted for. And it also has a period adjustment. Now be careful before you determine your period adjustment. Make sure to factor out the 2. That won't adjust your period, but it will help you better see your phase shift. This has the exact same phase shift as A. Make sure you factor that out. It's definitely in the 4.2 formula that you be factored out. And so we have So let me come in here and write some of the things that we need to accomplish. We need to go up 2, and we need to have a period of just pi now, not 2 pi, because we're going to divide 2 pi by 2, and we're going to have a phase shift of pi over 2 to the right. Okay, awesome. Let's handle all of that. Now, secant is based off of cosine, so I'm just going to draw the regular cosine graph, but paying attention to the phase shift and the period. Or sorry, not the phase shift, the amplitude and the period. Okay, so remember cosine starts up at 1, but now that's going to be up at a height of 3, and it falls down to 0. We'll go down to -3, come back up to 0, come up to a height of 3, come back down to 0, come down to a low of -3, and oh, look what I'm doing wrong. I'm putting it in black. Let me be careful here. Let me go, this is the helper graph, right? So let me be careful and put that in blue. So we'll do it a little bit quicker. Okay, down to -3, up to there. So let me make sure I did that right. Up 0, 3, down. So it's pretty steep. And you may be wondering, you're not considering the period adjustment. I will, right, in just a minute. Okay, so what did that take care of? That took care of the 3 so far. Now what I need to take care of is the period adjustment. So these used to be, the period now is pi. So, whoops, I hate when I do that. Sorry about that. Let's get back down to where we were. Oh boy. Okay. Sorry, this is not a great use of your time. Oh, okay, apologize. There's some review stuff at the end here that you can look at. For that, when I saw those, I thought that those were different settings. So here we go. This is where we were. So I'll try to avoid touching over there again. So now I need to realize that my period is only pi. So if this is 0, then I would come back to here at pi. That means this, oops, let me put that in black. That means this is pi over 2. This is pi over 4. This is 3 pi over 4. This is 5 pi over 4. Right? 3 pi over 2. And then so forth and so on. Right? Just these pi over 4 measurements instead of pi over 2. Everything's cut down in half. So that would be sufficient labeling for me. And then, so I've taken care of that. So now let's take care of the fact that we got to move this graph up too. No problem. Let's move that up too. So I'm going to get rid of this line, and I'm going to move it. I'm going to move that line 2 down. Right? Because that would move the whole graph up too. So now I've taken care of the amplitude that's been crossed out. Taking care of the +2. I've taken care of the period. So the only thing I haven't taken care of is a phase shift of pi over 2. Okay, no problem. I got to move this thing back pi over 2. So note that pi over 2, because I got to move it pi over 2 forward. Note that pi over 2 is 2 of these movements. And so my new axis is going to be right back here. That was 0, pi over 4. So this is negative pi over 4, negative pi over 2. So now this thing has been moved forward. What's left to do? Easy. Let's drop our asymptotes in every time that function. Oops. Let me go in red. Sorry, I thought I had selected red. Put my asymptotes in. Getting a little bit worried about having my hand over there. Put my asymptotes in where they belong. Okay. The asymptotes are usually done, if a book does them, in red. Okay, it looks like I got to get rid of a line for confusion. Sorry about that, not seeing that earlier. Perfect. Come over here, get rid of the rest of that. There's our new guy. So those are really, the axis is down here, so theoretically I should translate all those pi over 4s, but it doesn't really matter. But I'm just trying to give you a practical way to graph these guys and go up. And so consider this awesome in the sense that you have now a way to get these graphs out pretty quickly that's better than a graphing calculator. So you could get frustrated and say, well, why don't I just put this on a graphing calculator if you want me to get the picture? We don't want you to get the picture. We want you to be able to think, right? That's where your success in the future classes is going to come, not in your ability to parrot and to get things out on a calculator, but your ability to think through a problem. I think you're seeing that a lot with the 2.5, 7.1, 7.2, 7.3. You're having to think and put that in here. That's the design of this. So it'll be a sad experience if you're taking a graphing calculator on the test to produce the graph and just writing it down. That's not the intent of this. The intent is to have you apply all these things and really think about what needs to happen. My axis needs to move back. My axis needs to drop. My axis needs to go up. I need to label these out this way. Okay, so be careful on how you approach this study. As you look at these, they want to know what function this is coming from, and they're making sure that you understand that there's no phase shift. So these are just pure functions that are right here. So as we look at these, let's take a look and see what's happening. As we look at this guy, it seems to me that there is a period adjustment. If you look at the period adjustment, first of all, it's 0 at 0. And so since there's been no phase shift, we absolutely know that this is based upon the sine. So there's apologize. Let me just restate that better. There's an asymptote at 0. Because there's an asymptote at 0, the trig function that it's associated with evaluated as 0 is 0. So only sine of 0 is 0. So we know that this is cosecant. If we look at the period is pi. Right, it does its two complete revolutions in pi. Well, that's half the normal period, so this must be the cosecant of not 2 pi. Sorry about that. Good morning. This is 2x, and that one's done. It's going to be pretty hard to see if there's a number out in front. What does this one look like? Well, at 0, it's defined, so it cannot be cosecant, so it must be secant. And normally the secant graph would go up from a 1 position, but it's going down, so it must be the negative secant. And then let's take a look at the period. A full period is, let's see where we get a full period. I'll start at 0. Here I get that half, that whole thing. Looks like the period is pi over 2. Okay, so the period was 2 pi, but now it's pi over 2. So if you solve for that, you would find out that b is equal to 4 pretty quickly in that. So this is 4x, right? And I hope I'm not messing with you by not solving that every time. That should be pretty simple algebra for you. You actually should be quite worried if you can't understand where that 4 is coming from, because so much of your future classes, right, because you've all picked math science majors, which most likely will have you step into calculus, if you don't know your basic algebra, you'll fall apart there. And so we really should have seen that the pi's would cancel and the 2's would combine and 4 would be equal to b. I could show that stuff, but it's better for you to say, where'd you get that, and figure that out. Because we need you to be really algebra strong for lack of a better way to say that. If we look at this graph right here, it's definitely going to be a well, what would it be? Secant or cosecant? So we are defined here at 0. Okay, so therefore it's got to be a secant graph because it's got to be based upon cosine. And let's see what the period is. The period would be this whole thing. So let's see, not the whole thing. So up to here. So the period would be pi over 2, I guess. And then it looks like everything's been dropped down a level. Okay, and so if you look carefully, these marks are all 2. So this is 1 down. So it does look like this is a drop in 1. Does look to me to be a secant, right? It's a cosecant if it's an asymptote of 0. We don't have an asymptote of 0. And so it's a secant graph, and it looks like the period's been cut in half, that the full period is, well, interesting. From here to here is pi, and then we need to pick up the other 2. So it does look like it is the same period. So I would say it's that right there. And so that's what we're going to be dealing with. As we move to the next section, we'll be doing something totally different, but that they need to fit in somewhere, and they feel like this is the best place, harmonic motion. So I'll make a video about that as well.